Right. Firstly, hello. I'd just like to say this venue is absolutely incredible. I've been in the city for a couple of days, and I'd really recommend, if you have some time, going and seeing some of the sights of the city, like the castle, some of the churches, and the kind of high ground off this way. It's absolutely an amazing city. I've also been walking solidly for a couple of days, which means I'm absolutely knackered. So if I break down in tears halfway through, you know why. So this is me. I'm a front-end developer at Twitter. I work on TweetDeck. I have to have this slide just in case I forget my name, which happens sometimes. I spend some of my time playing this thing. This is a sousaphone. I'm in a band called the Neon Saints. You can look us up on Twitter and Facebook. And I don't normally play both of them, the trumpet as well. But when I work, most of the time, it looks like this, bottle of wine frequently in hand. And this is the product I work on, TweetDeck. I know a couple of people already who use this. Maybe you use it. It's actually quite likely that some of the accounts you follow, so the news accounts or some verified accounts that you follow, use TweetDeck. I think it's really great. It's kind of a power tool for Twitter. So firstly, a kind of disclaimer about this talk. We're kind of talking about the event horizon of web technology. This stuff is coming. It's not ready. It's not in the stable versions of browsers yet, but it is coming. So really my goal is to get you excited and get you interested. Some of this stuff is liable to change. But kind of with that in mind, I think it's really interesting to just look at this stuff and see what's coming down the pipe. So let's get started. This is a page that ruins people's days everywhere. We're used to seeing this page. If you're tethering, if you're in a coffee shop, or if you're in a kind of multitude of other places. I've had it quite a lot over the last couple of days without data roaming, so I go and sit somewhere and there's no Wi-Fi. But this page kind of reminds us, as people who build stuff for the web, that we have to face some hard truths. Truths like the fact that connectivity is simply just not ubiquitous. There's plenty of places I can think of, trains, in cars, when just walking around, or if you're in some kind of tunnel, particularly in a train. All those places you have no connectivity. We're kind of supposed to share experiences with each other, and that's what the kind of social platforms are for, and indeed, to a large extent, what the web's for. But the thing that we often forget is that all these services assume good connectivity. And have you ever noticed that the places where we have these experiences, like on a mountain or out in the countryside somewhere, are places where you have no connectivity? If the service is not set up to work in these places, then you simply can't use them as they were intended. And there are other things like developing countries where connectivity just isn't as good as it is in kind of Western nations. But I'm particularly thinking of Brazil and the World Cup. There were quite serious kind of connectivity issues and infrastructure issues in Brazil. The web in those places should be a viable platform. There is no reason we shouldn't be able to say to clients and bosses, the web is viable in these places, and we can build apps that will run in these places. But right now, we really can't say that with a straight face. So let's look at where we are now with the kind of options for offline. There are some technologies that are used to solve these problems. They tend to be just a kind of mishmash of what's available, put together in a kind of hacky way that works most of the time, but is missing some key functionality. That means there are surmountable problems. Technologies like local storage, IndexedDB, the hidden iframe technique, and techniques like having a client-side data model, syncing that later on, and batching up network requests. People are doing these things, but it's really not ideal. And asset delivery, which is a key component of this whole thing, which is something native has over the web, getting data and keeping it on the device, or getting data to the device and keeping it there. It's simply not up to scratch on the web. App Cache solves some of these problems, but it really is not the ideal solution. And it kind of makes developers feel like this kid. And as I said, this is maybe how I'll end up at the end of this talk. Some people are doing it well. Lanyard are a particularly good example, and the developers working on this spawned the app cache douchebag article, which is widely cited for kind of kicking off this whole discussion about what the web could be in offline scenarios. But this stuff is hard, and there are some people who aren't doing it particularly well. I hope nobody here works on this, and I'm sorry if I'm not really picking on them. It's just an example that kind of frustrated me in particular. This is DevDocs. This is a site I really, really like the idea of. It promises to give you offline access to the documentation of a whole range of projects. It uses app cache, so it sounds pretty promising, and the About page tells you that things will be available offline. And indeed, if you look in local storage, you can see there's a whole load of data there. You can see the libraries I have cached, and there's some data, so hopefully this thing is going to work offline. But as soon as you try to use the site when you're, say, in a train or you have no connectivity, this happens, which is a complete disaster and makes me feel like this. The reason is that they are caching the headers or the kind of titles and some metadata about the page, but not the actual content. So that means you can search for the documentation that you theoretically have cached, try to open it, and then it fails. So this is the message you see when you do that. Now, the other thing to notice about this page, and hopefully you can read it, is that it kind of tries to guess at what the problem might be. You know, that you could be offline, might be missing from the server, possibly a proxy, maybe there's a firewall. Really, there's no definite way to know what the actual problem is from the point of view of the developers of the site. That hints at a problem that we need to kind of, or a mindset shift that we need that needs to happen. Are we offline isn't the right question. Online is the real problem here. It's extremely hard, possibly impossible, to define online. Anywhere where you're in some kind of captive Wi-Fi kind of portal thing, like a coffee shop, like in a hotel. I've had this problem in my hotel, in an airport, or indeed in some trains. The requests appear to work. You may get a response. And it may even be a success response, but it won't be the response you're looking for. So techniques like pinging a server to see if you're getting something back completely fail. And there's the other problem of when you have some connectivity. So if you're out walking around town somewhere and you have one bar of signal, there's kind of a connection. Do you really have a connection? It's incredibly hard to tell. So we should work with that assumption and move our mindset to the offline first perspective. Now, this hashtag was kind of it was doing rounds on Twitter kind of recently. I think it's a really interesting idea and a really useful place to come at a problem from. The keystone of this idea is that the network is a potentially unavailable resource. So in the same way as we progressively enhance features like local storage, like geolocation, we can progressively enhance the network. After you've delivered your assets to the device, you then assume that there is no network connectivity, and then deliver your experience in such a way that when connectivity returns, you can deal with that and kind of give the user the best experience possible. And this means we have to start thinking about some things that we're currently not very good at on the web. Things like synchronization, giving the user feedback that an action is going to take place later on. What does it mean to send a tweet that isn't going to send just yet, but is going to send later on? What does it mean to check into Foursquare, but only when you actually have some connectivity? Clearly, there are problems with both of those. As I mentioned, Lanyard, also the Financial Times, and projects like Hoodie have been talking about this stuff for a long time. I found an article from 2012 that written by the FT that describes a lot of this stuff and is really impressive, but really the technology is lacking. And asset delivery is, of course, still tricky. The one other idea that we have to shift into our minds is this idea of there being a space constraint on the device. You simply can't have all available content on a device. This is kind of obviously true when you think about it, but sometimes websites will try and dump all the content they have available right now over to you. And this simply isn't going to work. We need to start thinking of the things we build as a kind of shell and some content. DevDocs is a good example of this. There's a kind of UI shell and then some content, but also tweets in TweetDeck, articles on The Guardian, all this kind of thing. There's some content that's a subset of all the available content that you want on your device, and there's some shell that contains the code needed to deliver that content. But right now, there isn't really a great way of doing this. As I said, App Cache offers some options, but we're still quite limited. So this is where this new technology, Service Worker, comes in. Adi mentioned it, but I'm going to take a kind of deep dive into it. Obviously, the name is pretty scintillating, but you kind of know it's good because it's got a boring name. Like lots of things have pretty boring names, like cardboard, toast, sleep. So like you know it's good. This is the kind of quickest summary I could come up with. It's a kind of web worker, so it's background JavaScript basically, not associated with a document. It responds to some new events that we haven't seen before, and it can create and manipulate these new objects, requests, and responses. It also has programmatic access to cache storage, and the cache storage maps requests to responses. So you can use requests made from the page or created manually to match previously made requests to get things out of the cache. And yes, it's HTTPS only. That's kind of the most condensed summary I could write and still achieve aesthetically pleasing slides. Remember, the first and goldenest rule of Keynote is content last. Now, I'm going to kind of insult your intelligence now. This is a conceptual overview of browsers. You probably kind of know this stuff. But I'm going to show you how Service Worker fits into this. App Cache fits in like this. The browser knows about App Cache and can talk to App Cache, but as developers, we have no direct access to App Cache. This is obviously problematic. So the Service Worker sits between the page and the browser and its network stack, and obviously, therefore, the network. And it can intercept requests made from the page. And that includes cross-origin requests. So if your page makes a request to another API, say GitHub's API or Flickr, or even just downloads images from another site, your Service Worker will see that request and can cache it and do all the things it can with other kinds of requests. As I said, it has programmatic access to your caches, and importantly, it will do nothing unless you ask, unlike App Cache, whose defaults are aggressive, to say the least. And like an extension background page, it's one-to-many, so you can have many pages open and they'll all be talking to one Service Worker. So let's have a look at some code used, the kind of thing we're going to start seeing in our code to use Service Workers. So first of all, you have to register your Service Worker. Now, I'm obviously omitting some things here like feature detection. Navigator in Service Worker is an easy way to do it. This registers, or this tells the page that there's a Service Worker available at this URL. The page will then go off and look for that worker, and then go through a series of lifecycle events, install, activate, and eventually your worker will start receiving requests from the page that it's controlling. You can also limit the scope of a Service Worker's, or the request a Service Worker is going to see. This would be really useful if you're working across a number of teams who control different parts of a domain or different paths. It means you can all have different workers and specify which part of the site you can control, and there doesn't need to be any violence in the office. This also has a promise API, so this specification depends quite heavily on promises. So you can give the user feedback if the Service Worker fails to install. Again, another thing you cannot do with App Cache. So this is creating and populating a cache. As I said, caches map requests to responses. So when we add some things to the cache, those URLs are converted into requests. They are fetched, and only when all the URLs I've listed here have all the promises there have fulfilled successfully, will that add promise, fulfill successfully. So that means we can respond to a cache being filled, and if it fails, we can respond to that, tell the user, or do the right thing. Really important that this is very, very explicit. We know what's going on at every stage. And because it's just JavaScript, we can debug this. And then you can persist a cache. So by default, a cache is not persisted. It will be filled, but it won't persist across worker restarts. So there's a global caches kind of map that we can persist a cache in, and then if our worker is killed, for example, if it has some kind of error, or if the browser just decides it's not interested in running your worker anymore, the worker will be killed. But when it comes back up again, this cache I've just created, app v1, will be available. I'm sorry, I'm a bit ill, so if I'm sounding a bit croaky, that's why. And you would do this kind of thing in the install step of a worker's lifecycle. So we can intercept requests from the page, and I'm using some ES6 fat arrow syntax here. So if it looks a bit crazy, or if there are syntax errors, it's because of that. But you can see we're adding an event listener. There's this new event called fetch, and what we're doing here is responding to that event. So there's a new method on this fetch event called respond with that takes a promise or a response. And we're matching the request in our cache. So it's looking at all the caches we have available and matching the request that we got from the page in those caches. If that fails, it will fall back to the default, which is to go to the network. So the first thing, this is kind of offline first. The first thing we're doing is going to the cache, then we're going to the network. And if the network fails, we have the option to generate our own response. So we can either do new response or pull something out of a cache somewhere else. You can also match on request type, so you can differentiate between an image request, a navigation, a script tag, so you can kind of do the right thing in every case. Here's a really cool thing that I'm sort of imagining that might be possible. Here, I'm racing two caches against the network. This would be really, I think this is interesting because we can do things like, say, I've got a content cache, which is things that I know the user wants. So you could, for example, have a button on the page that the user clicks, and that makes the content associated with that button available offline. It puts it in the cache. Or we have a kind of a cache, a sort of smaller cache with some eviction policy, where we say we're going to cache the last 10 things you looked at. So that might be the last 10 YouTube videos you looked at, or I don't know, the last some emails that you just read. And that's kind of a moving window. And so it may or may not contain the thing that's just being requested. And then we also, at the same time, kick off requests to the network. That means if it's in the content cache, we'll get that straight away. If it's in the kind of recently used cache, we'll get that straight away. And if all that fails, we will go to the network. And of course, we can catch all failures all failures there and do the right thing again. This is untested, so don't necessarily try and run this. But this is the kind of thing that we can do that we need to start exploring. So where are we with service workers? Well, it's not really in browsers yet. The spec is at first draft. It's on GitHub, and it has landed in Chrome Canary. Google, Mozilla, and Samsung are working on it, along with others from the open source community. And it's on GitHub, and that's the URL. Hopefully, you can see that URL. The really nice thing about it being on GitHub is it's not behind a quite unfriendly mailing list. I said it's not in browsers. Google are hoping to have it in Chrome this year. Mozilla have committed to implementing it in Gecko. WebKit, people have expressed an interest in it, but unfortunately, as far as I know, Microsoft and Apple have been silent on it. Obviously, the important one there may be the fruit seller, but it will be interesting to see if it landing in the Android browsers will be kind of a forcing function on Apple to implement it. So if you want to play with this now, and you can right now, open up Canary, update it, and make sure you have this flag turned on. Thank you very much to Addy. I'm not quite sure where he is, but for pointing out today that this was in Canary. And you can try this stuff out right now. Jake Archibald has put together a demo. I also have one, but it's not as good as Jake, so I'd go play with that if I were you. My involvement in this stuff is I built a JavaScript-only implementation. It was kind of slightly crazy hackery. There was a Chrome extension involved, Node as a proxy server. We used some VM API stuff. You can see it there. It's kind of out of date now and also a bit pointless because it's in Canary. the future of this stuff, I'm kind of sort of speculating, but some specifications are in the works that depend on the service worker specification. Background sync API, the push API, task scheduler will all depend on service workers and will integrate tightly with it. And this really is pure speculation. I can see a future where our frameworks are auto-generating our service workers. Angular, say, has resources, meaning it understands roughly the HTTP architecture and the requests that your application is going to make. That might mean it can look at your application and auto-generate you a service worker. There's a possibility for a responsive image solution here. There's going to be a lot of great things we can do with installable websites and background tasks like keeping music running in the background, tracking where you are, and kind of mundane but extremely useful things like alarms. So I guess it's kind of your turn. Get involved in the spec. Understand the UX implications. Try things out. What does it mean for your particular use case to work offline? And push this spec to the limits, because we need to get this right now, because we got it so wrong with app cache. So thank you very much. You can either tweet me, my handle's on there, or use that hashtag, or just kind of come find me afterwards. Thank you very much.